represent a horizontal distance of a flagpole from its resting position we should say horizontal distance in centimeters of a flagpole from its resting position at t seconds. Okay, so then our formula is F at t equals, so the amplitude's first, so 10 sine bracket 1440 t, and then nothing. We don't need to do, we don't need to add plus 0. So, and we're used to saying for the all time greater than or equal to 0. It didn't give us any time for how long this is doing it. Okay, so there's our function. We analyzed everything. The amplitude comes first. The k value is here. There's no phase shift and no change in the axis. So what if the wind speed decreased slightly such that the sway is reduced by 20%? Okay, assume the period remains the same. You can draw this below if it's getting tight, but I'm not going to move it because I want to keep all this information. So 20% of 10 meters, what is that? That's 8 meters. So the sway is reduced by 20%, so that means that my maximum is now 8, and my minimum is now -8. So instead of my amplitude being 10, my amplitude is now 8. So you would just have F at t equals 8 sine 1440 t, because it said the period remains the same. All right, so this is a 20% reduction in the amplitude is what's happening there. So the graph, the orange graph, is a vertical compression of the black graph. Phew, that's a lot of modeling. So I hope those examples will help you when you're going to be doing some of your own modeling, when you model windmills and other things. So I hope you're able to really understand these examples so that you're able to apply these concepts to other real life situations. Thanks for watching. Hope you learned lots.